Question 9.63. A car accelerates uniformly from rest and reaches a speed of 22.0 meter per second in 9 seconds. The diameter of a tire on this car is 58.0 centimeter. Part A of the question is asking us to find the number of revolutions the tire makes during the car's motion, assuming that no slipping occurs. In part B, want us to find the angular speed of the tire in revolution per second. So let us first write down what is given to us. We have a car that accelerates uniformly from rest. From rest means the initial speed of the car has to be zero. So we can write V initial to be equal to 0 meter per second. And then it reaches a speed of 22.0 meter per second, which is my final speed, 22.0 in 9 seconds. So I will write the time t to be 9 seconds. The diameter of the car's tire T is 58.0 centimeter. So you can find the radius of the car tire by using the diameter. The radius R will be diameter by 2, which is 29.0 centimeter. And I can write this in meter by dividing this number with 100. So that will become 0.29 meter. This is the radius of the car's tire. So we need to find what is the number of revolution n in the first part. And in the second part, we need to find the angular speed of the tire in revolution per second. So let us start with the first part. We can find the number of revolution n by taking the ratio of delta theta over 2 pi. So if I need n, I need to know what is the angular displacement delta theta. And to find the angular displacement, we need to first find what is the linear displacement of the car. So I have the initial velocity, the final velocity, and the time. I can calculate the linear displacement by using the first equation of motion, which says x final equals x initial plus v initial t plus half at squared. So we can move this to the other side. That gives me x final minus x initial, which is my linear displacement, equals v initial t plus half at squared. Now substitute x final minus x initial, I can write as delta x, which is equal to v initial is 0. So 0 times anything will give me 0 plus half at squared. So I get my delta x to be equal to half at squared. Linear acceleration a is not given to us, but I can find this linear acceleration a using the velocity values and the time t. We know that acceleration a is defined as a equals change in velocity over the time. The change in velocity is nothing but final minus initial velocity over the time t. So here in delta x, I can substitute this for a, or I can calculate a first and then solve for delta x. So let us find what is the linear acceleration a. V final is 22, V initial is 0, and the time t is 9 seconds. So you get your acceleration as 22 over 9 meter per second squared. I will substitute this in delta x and get me my linear displacement. So we get delta x to be equal to half. Value of acceleration is 22 over 9 and the time t is 9 squared. When you solve this, you get delta x to be equal to 99 meter. Once I found the value of delta x, I can calculate theta. I know that linear displacement delta x is related to angular displacement by r times delta theta. So I can find delta theta to be equal to delta x over r. And when you solve this, you get delta x to be 99 divided by r, which is 0.29. That gives me my total angular displacement to be equivalent to 341.4 radian. After we found the angular displacement delta theta, now I can calculate the number of revolution. Number of revolution n is equal to delta theta over 2 pi, which is 341.4 divided by 2 pi. That gives you the number of revolution as 54.33. And since it's a number, there is no unit for the number of revolution. In part B of the question, they want us to find final angular speed of a tire in revolution per second. So final angular speed means we need to find what is omega final. But this has to be in revolution per second. So angular speed in revolution per second is basically equivalent to finding the frequency. So we need to basically find what is the frequency of the tire in order to know what is its final angular speed in revolution per second. We know that omega and frequency are related to each other, and we can write omega final as 2 pi times f. So if I know the value of omega final, I can calculate my frequency as omega final over 2 pi. So let's find out what is omega final, and then we can substitute its value here to find the angular speed in revolution per second. We have the final linear speed, and we know that linear speed and angular speed are related to each other by the expression linear speed v is equal to r times the angular speed. So I can find angular speed omega by dividing the linear speed with the radius r. So we can get omega final as v final over r, which is v final is 22 meter per second. The radius is 0.29. And when you solve this, you get omega final as 75.86 radian per second. Now this is your angular speed in radian per second. And I need to find the speed in revolution per second. So I will find that angular speed in revolution per second by dividing this angular speed in radian per second by 2 pi. So let's solve. Let's complete this part. Omega final in radian per second is 75.86. Divide this by 2 pi. And when you solve this, you get your answer as 12.08 revolution per seconds. So anytime they ask you to find angular speed in revolution per second or revolution per minute, they're basically asking you to find the frequency, angular frequency of the object.